Hello friends, today's question. A spring block system is resting on a frictionless floor as shown in figure. The spring constant is 2.0 Newton per meter and the mass of the block is 2 kg. Ignore the mass of the spring. Initially, the spring is in unstretched condition. Another block of mass 1 kg moves with a speed of 2 meter per second, collides elastically with the first block. The collision is such that 2 kg block does not hit the ball. The distance in meters between the two blocks when the spring returns to its unstretched position for the first time after the collision is. In this case, let us try to understand by drawing the figure first of all how the entire system is going to change when the two blocks are going to collide with each other. So let us call this as block A and this as block B. Initially block B is stationary and block A is moving with a velocity of 2 meter per second and it strike block B. So this is, let us consider this situation just before collision. Just before collision. And this is A, this is B, and this is the position just at collision, okay, or we can say during collision. And during the solution of the question, we are also going to find out that the respective velocity of the block A as well as block B after the collision. Okay, so let me draw the figure first. So the block A will move in this direction and block B will start to move towards the right direction. Okay. So let us assume that block B is moving with the velocity of VB and block A is now moving with the velocity of VA, and here the velocity of block A is UA and it is UB, which is equal to 0, and UA is given as 2 meter per second. Now block B will try to travel to the maximum displacement position, okay, and this is after collision. After collision. Now the block B will try to you can say travel to the maximum displacement position, and the question itself it's given that block B do not hit the wall rather. Okay. So it means you can say that block B, the spring is compressed to its maximum extent like this, and this is the extreme position of the block B, and the block A is somewhere here. And at this particular moment, we can say that block B is at maximum displacement towards the right. Block B is at maximum displacement towards right, and block A is still traveling like this, and at this particular moment at maximum displacement this block will be, for a fraction of a second, it will be stationary. Now, and if this is the mean position, that is initial position of block B, then the question itself is asked that first time the block B will return to its mean position such that this entire spring is now unstretched. So for this, the block B will be traveling in this direction with the velocity of VB. We will later on change the sign also, and it is still traveling with velocity of VA, and this is our block A traveling with the velocity of VA, sorry, not VB. So this is a return to the original position. A return of block B to unstretched position. Unstretched position. So this is the unstretched position for block B. So this is the, we can say, basic question or basic description of the question with respect to figures. So we are mainly interested that at this very moment, what will be the distance between these two? Okay. We have to find out this distance between the two blocks. When the block B is at the equilibrium or unstretched position, block A will be somewhere else traveling with the velocity of VA. And we are going to find out what will be the velocity of VA as well as VB. For that, we are going to use conservation of momentum. Okay. You can say conservation of momentum. Conservation of momentum. So let's find out initial momentum, that is momentum before collision. Initial momentum, that is before collision, that is P initial will be equal to mass of A multiplied by velocity of A plus mass of B multiplied by velocity of B, where this MA is the mass of block A. You can say MA. MA is mass of block A. MB is mass of block B. UA is initial velocity, UA is initial velocity of block A. UB is initial velocity of block B, and it is given that before collision block B is at rest. So from here you can say UB is equal to 0 and UA is given as 2 meter per second. UA is 2 meter per second. So we can write our P initial will be equal to 1 multiplied by 2 plus 2 multiplied by 0. This will be giving us 2. Momentum initial is equal to 2. Now let's find out final momentum. Final momentum, that is after collision. So we say P final will be equal to MA VA plus MB VB, where VA is the velocity of block A after collision. VA is velocity of block A after collision, and VB is velocity of block B after collision. And we know P initial should be equal to P final, conservation momentum. P initial is equal to the final, so which gives us that 2 is equal to MA VA plus MB VB. We substitute value of mass, we get VA plus twice VB is equal to 2. Equation number 1. And it is given that collision is elastic. Okay. We are given that it is elastic collision. It means the coefficient of restitution E will be equal to 1. So therefore we can write that 1 will be equal to VB minus VA divided by UA minus UB, and we can write this as VB minus VA, it will be equal to 2. So therefore we can write VB minus VA is equal to 2. Let this be equation number 2. So now we have two equations, equation 1 and 2. We are going to use it and find out value of VA and VB. From equation 1 and 2, we get equation 1 was VA plus twice VB is equal to 2, and here we have VB minus VA is equal to 2. So if we add them, these two terms cancels out, we get 3VB is equal to 4, or VB is equal to 4 by 3 meter per second. So we got VB. Now we can find out VA. Therefore, we can write that our VA will be equal to minus of 2, and we have plus of VB, which is minus of 2 plus 4 by 3, and this gives us that VA is equal to minus 2 by 3 meter per second. So VA will be traveling in the opposite direction to our VB. And we can also write that the time period of spring block system, because it is going to have a spring system and that results in a, you can say, SHM. So therefore we can write that the time period for spring block system, and here block is block B, that T is equal to 2 pi mass of block B divided by K, and spring constant is given as 2. So we get 2 pi, mass is also 2 pi divided by 2, and this is equal to, comes as 2 pi second. So this is the time period for the block B spring system, but we have to find out the time when this block crosses the mean position or unstretched position first time. Okay, and the time period is for the entire section. For this half, this particular section, when it is crosses the, it is going to cross this, the mean position first will be given by T divided by 2, that is 2 pi divided by 2. So we can say that halfway path will be traveled by the block B, in time is equal to 2 pi divided by 2, and that is equal to pi seconds. We can approximate a rough figure for that also. So this is the mean position, and the block B is here when the spring is completely compressed, and this is suppose one extreme position. Let us suppose this is our plus of A, then the block will be traveling a plus of A up till here, that is minus of A, and this is block B as well as block B. This is the total time period T, which is given as 2 pi. But we have to find out the first instant when this block B is going to pass through the mean position. So this time period will be equal to half of this total time period, that is 2 pi divided by 2. Let us put here small t. So this will be equal to our small t. Okay. So it means block B, it returns to its original position first time in pi second. So you can say that block B returns to its original position first time in pi seconds. So in the figure we just also concluded that block A will be moving towards the left after the collision, and block B will also be moving towards the left when it is going to pass through its unstretched position. So both the blocks will be traveling the same direction. So you can say that after collision, block A moves towards left. After collision, block A moves to left with velocity VA, and that we calculated is -2/3 meter per second, and you can say that but for block B to return to unstretched position, it should also be moving to left with velocity, and that velocity will be nothing but VB, but with negative sign, that is -4 meter per second. So now we can find out the relative velocity between block B and block A. Relative velocity between block B and block A, let us call this as V relative, which is equal to VB minus VA, this is -4/3 and -2/3. So we get V relative is equal to -2/3 meter per second. Now we are going to find out distance, because we already found out that the time period is pi second. So we have to find out what will be distance at t is equal to pi second, and the velocity is, relative velocity is rather -2/3. Therefore we can say the distance between two blocks distance between the blocks after pi seconds. Let us suppose that distance is given as d, which will equal to v relative multiplied by t. This is 2 by 3 and multiplied by pi. This is 2 by 3, pi is 3.14. So we get d is approximately equal to 2.03 meters. Okay. So this is the distance between the two blocks when the spring returns to unstretched position for the first time after the collision. So we can say this is the distance between the two blocks when spring returns to the unstretched position for the first time. After collision. So herein the spring is said to be returning to the unstretched position. So basically means indirectly block B is returning to unstretched position. Okay. So this completes the question. Thank you.